What if airplanes could feel the air around them, like birds do? Imagine sensing turbulence before it hits and adjusting in real time for a smoother, more efficient flight. Right now, though, that's not how planes work. Aircraft mostly rely on instruments and manual controls, which don't react fast enough to sudden changes in airflow. This can lead to turbulence that shakes the plane, which makes it uncomfortable for the passengers. In some cases, it can even cause a more serious problem like stalling, where the wing loses lift and the plane starts to fall. But don't blame it on the pilots, because the systems don't provide the real-time data they need to make quick adjustments. That's why turbulence often catches us off guard. But what if there was a way to change that? What if we could make aircraft not just rely on instruments, but actually sense the air around them? That's where aerodynamic skin comes in. A 5-year research project supported by the Royal Academy of Engineering and BA Systems and led by Professor Christoph Bruecker. The goal is to create tiny hair-like sensors that will be integrated into aircraft surfaces. But how exactly can these hair-like sensors detect changes in airflow? That's where the breakthrough research titled Fly-by-Feel Flow Event Detection via Bio-Inspired Wind Hairs comes in. This study was inspired by the peregrine falcon, bats, and seals, who all use similar sensing hairs to navigate their environment. To find the answer, the researchers took a hands-on approach, setting up an experiment to test how these sensors respond to real-world flow conditions. The researchers set up their experiment in the low-speed water tunnel at City, University of London, attaching 6 flexible wind hair sensors to a NACA 0012 wing. The tips of these sensors were coated with fluorescent dye for easy tracking. To simulate real flight conditions, they used a flaplet system to create gusts and turbulence in the water. A color filter camera tracked the bending of the pillars, revealing how the sensors responded to airflow disturbances and helping the team assess their ability to detect changes in airflow. With the sensors in place and the airflow disturbances simulated, they were ready to make measurements. What they discovered was quite promising. The sensors were able to detect the gust-induced disturbances and track the changes in the airflow. As the gust passed, the pillars bent in response, allowing the team to measure the arrival time and movement of the starting vortex. This provides useful data on how the sensors could potentially be used to measure real-time flow changes in the air. Now, I personally think this data is a big step forward because it brings us closer to creating aircraft that can adapt in real time to changing air conditions. One recommendation that I could think of when reading the paper is using piezoelectric sensors instead of the optical camera system. Piezoelectric sensors provide a direct, highly sensitive measurement, making it more effective for real-time data collection. While I do understand the advantage of optical camera of not interfering with the flow, I think the piezoelectric sensors would provide more reliable data. And now for all the meme haters, you're in luck, because there is a meme waiting for you at the end. See you guys next Wednesday, and do you think this technology could be adapted to drones? Let me know below.